When people say that a mirror reverses left and right, they are describing an experience that feels undeniably real. You raise your right hand and the reflection raises what appears to be its left. You part your hair on one side and the image shows it on the opposite side. This daily encounter seems so obvious that questioning it feels unnecessary. Yet this is precisely the kind of everyday certainty that fascinated Richard Feynman, because it hides a deeper misunderstanding about how space, orientation, and perception work together. A mirror, in physical terms, is a remarkably simple object. It does not know what left or right is. It does not care about human bodies, faces, or gestures. It reflects light according to a single rule: the angle at which light arrives equals the angle at which it leaves. Every photon that strikes the mirror bounces back symmetrically. From the mirror's point of view, there is no preference for horizontal or vertical directions. There is only one meaningful distinction: the direction perpendicular to its surface. That direction is what we casually call front and back. When you stand in front of a mirror, the front of your body is facing the mirror. The light coming from the front of you strikes the mirror and returns toward your eyes. The mirror does not rotate anything. It does not twist the image. It simply sends light back along the same paths, reversing depth. Points closer to the mirror appear closer in the reflected space, and points farther away appear farther. The only axis that changes sign is the one pointing into and out of the mirror. This front-back reversal is not intuitive because humans rarely think in terms of depth as a reversible direction. Left and right are easy to label because we experience them constantly through symmetry in our bodies. Up and down feel absolute because gravity fixes them in place. Front and back, however, are psychologically slippery. We instinctively imagine ourselves moving forward into space, not flipping forward and backward like coordinates on a graph. As a result, when front and back are reversed, our brains look for another explanation. To understand this, imagine a simple coordinate system attached to your body. One axis points upward through your head, one axis points sideways through your shoulders, and one axis points forward through your chest. When you look in a mirror, the upward axis remains unchanged. The sideways axis remains unchanged. Only the forward axis flips. The version of you in the mirror is facing you because its forward direction points opposite to yours. That is the entire transformation. Nothing else has been reversed. But this description clashes with how we instinctively interpret what we see. We do not normally think of the reflection as a version of ourselves with reversed depth. Instead, we imagine it as another person standing where the mirror is. Once that imagined person is placed there, we mentally rotate them to face us, because that is how two people normally interact. This imagined rotation is subtle, automatic, and almost impossible to notice, but it changes everything. When a person rotates 180 degrees around a vertical axis to face someone else, their left and right sides switch relative to the observer, while up and down remain the same. This rotation is not performed by the mirror. It is performed by the observer's imagination. The mirror simply presents a front-back reversed image. The mind adds a rotation to make sense of it socially and spatially. The result feels like a left-right reversal, even though none has occurred in the physics. This is why the illusion feels so stable. It is reinforced by how humans interact with other humans. When you stand face to face with someone, their left hand aligns with your right side of vision. That experience becomes a template. The mirror reflection fits into that template almost perfectly, so the brain treats it as another person facing you. Once that assumption is made, left and right seem flipped by comparison. Feynman emphasized that if mirrors truly reversed left and right, they would also reverse up and down, because physics has no reason to favor one horizontal axis over the other. A true left-right reversal without an up-down reversal would require a mirror to distinguish between directions parallel to its surface, which it cannot do. The laws of reflection are symmetric. Any explanation that singles out left and right is already suspicious. A useful thought experiment is to imagine writing the word hello on a transparent sheet of glass and then looking at it from the opposite side. The word appears reversed left to right. No mirror is involved at all. What has happened is purely a front-back reversal. The letters are facing away from you instead of toward you. The effect is identical to what a mirror produces. This shows that left-right reversal is not a special property of mirrors, but a consequence of viewing objects from the opposite side. The same idea applies to your own body. Your face is not symmetric front to back. Your nose sticks out. Your eyes are set into your skull. When the mirror reverses depth, it presents a version of your face that has been turned inside out along the forward axis. You then unconsciously reinterpret that image as a person facing you. In doing so, you mentally rotate it, and the apparent left-right swap appears. Another way to see this clearly is to consider how mirrors behave with text placed directly on their surface. If you write a word on the mirror itself using lipstick or a marker, the writing does not appear reversed when you look at it. The mirror does not flip the text because the text lies in the plane of the mirror. There is no front-back depth to reverse. This alone should be enough to show that mirrors do not inherently reverse left and right. The confusion persists because human perception is not built to analyze coordinate transformations. It is built to recognize faces, interpret social cues, and navigate environments quickly. When perception encounters a situation that does not match everyday interaction rules, it fills in the gaps using familiar patterns. The mirror becomes a social object rather than a physical one, and the physics fades into the background. Feynman loved pointing out that many deep confusions in science begin this way. We take a familiar experience, apply a misleading mental model, and then become puzzled by the result. The mirror is a perfect example because the experience is so common that nobody thinks to question the model behind it. The surprise is not that the mirror seems to reverse left and right, but that it took so long for people to realize it never did. This insight also reveals something profound about symmetry. A mirror creates what physicists call a parity transformation along one axis. It changes the sign of the coordinate perpendicular to its surface. That operation alone does not produce a left-right swap unless combined with a rotation. The rotation is supplied by us. In other words, the mirror provides the mathematics, and the mind supplies the illusion. What makes Feynman's explanation powerful is not just that it solves a puzzle, but that it exposes a habit of thought. We often believe that perception is a direct window into reality. The mirror shows how indirect it really is. What we see is shaped by assumptions, expectations, and learned interpretations layered on top of raw sensory data. This is why the explanation feels mind-blowing to many people. It forces a separation between what is physically happening and what is psychologically inferred. Once that separation is clear, the mystery vanishes, but it leaves behind a sense of humility. If something as simple as a mirror can fool us so completely, how many other everyday experiences are we misinterpreting without realizing it? The mirror, then, becomes more than a household object. It becomes a lesson in how science works. Science does not accept obvious answers. It asks what exactly is being measured, transformed, or observed. In this case, the answer is precise and almost boring. Mirrors reverse front and back. Everything else is storytelling added by the human brain. Understanding this does not make mirrors less fascinating. It makes them more so. Every glance at a reflection becomes a quiet demonstration of geometry, optics, and cognition working together. The reflected world is not a distorted version of reality. It is reality viewed through a different orientation, filtered through the assumptions of the observer. This is why Feynman enjoyed such questions. They remind us that the universe is not strange in the way we often think. It is consistent, elegant, and honest. The strangeness comes from us, from the shortcuts our minds take to survive and make sense of the world quickly. The mirror simply exposes those shortcuts. In the end, saying that mirrors reverse left and right is like blaming a book for being hard to understand when we are reading it upside down. The problem is not the object, but the orientation. Once that orientation is corrected, the confusion disappears, and what remains is a clearer picture of how perception and physics quietly intersect in everyday life. The idea that the confusion about mirrors comes from how humans imagine swapping places with their reflection may sound subtle at first, but it cuts straight to the heart of why this illusion feels so convincing. The mirror itself performs a simple physical action, yet the human mind cannot help but add an extra layer of interpretation. That added layer is not accidental. It is rooted in how we understand bodies, faces, and social interaction in three-dimensional space. From the moment we are born, we learn to recognize other people by facing them. Eye contact, gestures, expressions, and movement all happen most naturally when two individuals stand face to face. Our brains become experts at interpreting what another person looks like from the front. This skill is so deeply embedded that when we see something resembling a face aligned toward us, we instantly classify it as another person, even when we intellectually know it is just a reflection. When you stand in front of a mirror, the reflection looks directly at you. Its eyes meet yours, its facial expressions match your own, and its movements respond instantly. Every cue that normally signals another person is present. The brain does not treat the reflection as an optical phenomenon. It treats it as a body occupying space opposite you. This automatic interpretation happens faster than conscious thought, and once it happens, everything that follows is shaped by it. At that point, the mind performs a silent act of imagination. It assumes that the reflected person is standing where the mirror is. But the mirror is facing you, and people normally do not stand facing someone while also facing away from the same direction. To make sense of this, the brain implicitly rotates the imagined person so that they are oriented in a familiar way. This rotation is never noticed because it is not visualized step by step. It simply feels correct. That imagined rotation is the source of the apparent left-right reversal. When a human body rotates to face someone, left and right exchange places relative to the observer. This is not a property of mirrors. It is a property of rotating objects in space. The brain applies this rotation automatically, then attributes the result to the mirror, even though the mirror did not perform it. This mental habit is so strong that even when people are told the correct explanation, their intuition resists it. They may understand it logically, but when they look into a mirror again, the illusion returns instantly. This shows how powerful embodied thinking is. Our sense of left and right is tied to our physical orientation, not to abstract coordinate systems. Feynman emphasized that human intuition evolved to help us move, survive, and interact, not to analyze optical transformations. When intuition encounters a situation outside its everyday toolkit, it still tries to help, but it often does so by oversimplifying. The mirror becomes a stage for this simplification. Instead of thinking in terms of light rays and axes, the brain substitutes a familiar scenario, another person facing you. This substitution explains why the illusion feels personal rather than technical. You do not just see an image reversed, you see yourself reversed. Identity becomes part of the confusion. You are deeply aware of which side of your body is left and which is right. When the reflected version seems to contradict that awareness, it feels like the mirror is actively violating something fundamental. The sense of violation grows stronger because we rarely imagine swapping places with objects. We do not imagine switching positions with a chair or a wall. But with another person, especially one that looks exactly like us, the idea of swapping places feels natural. The reflection invites comparison, imitation, and role reversal. The mirror does not force this. The human mind eagerly supplies it. Consider what happens when you raise your right hand. You feel the muscles move, you see the motion, and you see the reflected hand move simultaneously. The synchronization strengthens the belief that the reflection is performing the same action from the opposite side. The mind fills in a story of correspondence between two bodies. One is you, and the other is you, but over there. Once this story is in place, spatial reasoning follows social reasoning instead of physical reasoning. You think about how you would appear if you were standing where the reflection appears to be standing. To do that, you imagine turning around to face yourself. That imagined turn reverses left and right. The illusion is complete, and it feels unavoidable. This explains why up and down never seem reversed. When you imagine swapping places with another person, you do not imagine flipping upside down. Gravity anchors that axis. The imagined rotation is horizontal, not vertical. As a result, left and right appear to change, while up and down remain stable. The mirror is blamed for a transformation that the imagination quietly performed. The same mental process can be observed outside of mirrors. When you look at a photograph of someone facing you, their left side appears on your right side of the image. You do not think the photograph has reversed left and right in a mysterious way. You simply understand that the person is facing you. The mirror creates a similar situation, but with motion and depth added, making the illusion far more compelling. Feynman's insight here is not merely about mirrors, but about how humans mistake relational descriptions for physical processes. Saying left and right only makes sense relative to an observer's orientation. When that orientation is changed or imagined differently, the labels change too. The mirror does not change the labels, we do. This becomes especially clear when you stop imagining yourself in the reflection's place, and instead imagine the reflection staying exactly as it is, without any mental rotation. If you think of the reflection as a version of you with reversed depth, not as a person standing and facing you, the left-right confusion weakens. But maintaining that perspective is difficult because it goes against social instincts. The mirror thus exposes a gap between geometric truth and psychological comfort. Geometry describes transformations precisely and without preference. Psychology prefers interpretations that fit familiar bodily experiences. When these two systems collide, the mind chooses comfort and blames the object. Feynman often pointed out that understanding physics requires resisting this impulse. One must describe what is actually happening, not what feels like it is happening. In the mirror case, what is happening is simple and consistent. What feels like it is happening is a story built from habit. This habit explains why people often insist that mirrors flip images horizontally. Horizontal flipping is a concept borrowed from books, screens, and photographs, not from physical reflection. We project that concept onto the mirror because it matches the story our mind is telling. But the mirror does not know what horizontal means. It only knows how to reflect light. The illusion is reinforced by language itself. We speak of your left and my right as if they were absolute properties, when in fact they are relational. When you imagine being in another place, the relations change. Language hides this complexity, making the mirror's behavior seem paradoxical when it is not. This also explains why children sometimes struggle to identify left and right, but have no trouble with up and down. Left and right depend on orientation and perspective. The mirror challenges that dependence in a dramatic way, revealing how much of spatial understanding is learned rather than innate. The deeper lesson here is that perception is an active process. We do not passively receive images from the world. We interpret them, frame them, and embed them in narratives. The mirror provides raw visual information, but meaning is supplied by the observer. When that meaning involves imagining oneself in another position, distortions naturally arise. Feynman valued this example because it demonstrates how easy it is to confuse description with explanation. Saying that a mirror reverses left and right describes an experience, but it does not explain a mechanism. Once the mechanism is examined, the description falls apart, revealing the role of imagination in creating the effect. This insight matters beyond optics. In many areas of science, from relativity to quantum mechanics, our intuitions fail because we insist on imagining ourselves at the center of the system. We ask what something looks like from our point of view, then assume that view is universal. The mirror shows how misleading that assumption can be. By recognizing that the left-right reversal comes from imagining a swap of places, we gain a small but powerful tool, the ability to separate physical transformations from mental ones. The mirror becomes a training ground for clearer thinking. It invites us to notice when we are adding something that is not really there. Once this realization settles in, the mirror no longer feels deceptive. Instead, it feels honest, even generous. It shows exactly what it does, and in doing so, it reveals something about us. The illusion does not disappear entirely, but it becomes transparent. You can feel it happening while knowing why it happens. That awareness is what Feynman considered genuine understanding. Not the elimination of confusion, but the ability to see its source. The mirror continues to show the same image as before, but now the mystery has shifted. The question is no longer what the mirror is doing, but how the mind insists on completing the picture in its own familiar way. In this sense, the mirror is not a trickster, it is a teacher. It quietly demonstrates how imagination, habit, and bodily experience shape perception. The reversal we think we see is not imposed by glass and silver, but by the deeply human tendency to step into another position, turn around, and see the world as if we were standing there instead. The idea that orientation, not reflection, creates the illusion of left-right reversal pushes the mirror mystery into even deeper territory, because it forces us to confront how strongly our sense of space depends on how we are oriented within it. The mirror itself remains passive throughout the entire process. It reflects light faithfully and without preference. The confusion arises only when the human observer tries to interpret that reflected space using bodily orientation as the reference point. Orientation is one of the most basic tools the human mind uses to understand the world. From early childhood, we learn where we are in relation to our surroundings by anchoring directions to our bodies. Forward is where our eyes face. Backward is where we cannot see. Left and right are defined by asymmetries in our bodies, by which hand writes and which foot steps first. These directions are not properties of space itself. They are properties of how we exist within space. Because of this, spatial understanding is never neutral. It is always centered on the body. When you move, the coordinate system moves with you. When you turn around, left and right change places relative to the environment, but inside your mind they still feel stable because they remain attached to you. This attachment is so strong that we rarely notice it, until something like a mirror exposes it. When you face a mirror, your orientation in space is very specific. You are facing forward, standing upright, with gravity defining up and down. The mirror presents an image that is also upright, also facing forward, but facing in the opposite depth direction. The image's orientation in space is not the same as yours, even though it feels that way. The difference lies along the front-back axis, which is the axis humans pay the least attention to consciously. Because the reflection is upright and responsive, the mind treats it as sharing the same orientation. This is where the illusion begins. The brain assumes that if something looks upright in face, then its left and right must correspond to some version of human left and right. But that assumption quietly ignores the fact that orientation has changed. If orientation were removed from the equation, the illusion would collapse. Imagine floating in space with no gravity, no up or down, and no sense of bodily dominance. In such an environment, the idea of left and right would lose much of its meaning. A mirror floating nearby would simply show a reversed depth image, but there would be no preferred way to interpret it as flipped horizontally. The illusion depends on stable orientation cues. This is why gravity plays such an important role. Up and down feel absolute because gravity constantly reinforces them. Even when we rotate or lie down, gravity provides feedback that helps the brain maintain a consistent sense of vertical direction. Left and right, by contrast, are free to swap whenever orientation changes. The mirror exploits this asymmetry perfectly. Feynman pointed out that when people say mirrors reverse left and right, they are really saying that mirrors conflict with how they expect orientation to behave. They expect that a reflection should preserve all bodily directions except perhaps depth. When it does not fit that expectation, the brain resolves the conflict by inventing a left-right reversal. Orientation also explains why the illusion disappears in certain contexts. If you look at a mirror image of an arrow pointing forward, the arrow points backward in the reflection, not left or right. No confusion arises. But when the object has a front that resembles a human face, orientation assumptions return instantly. Faces are orientation, heavy objects. We are experts at reading them. This expertise becomes a trap. The mirror reflection of a face is treated as a face with an orientation, not as a geometric transformation. The brain assigns it a posture, a stance, and a spatial role. Once that happens, orientation dominates interpretation, and reflection becomes secondary. The same effect can be observed when people view themselves on video. If the video is mirrored, movements feel natural because they match what people expect from mirrors. If the video is not mirrored, movements can feel wrong, even though they are more accurate representations of how others see them. This discomfort comes from orientation expectations, not from optical errors. What feels correct is not what is physically accurate, but what aligns with bodily orientation habits. The mirror image feels right because it matches the orientation-based story the brain is telling. That story includes an imagined body standing opposite you, oriented in a familiar way. Orientation also explains why the illusion persists even after learning the correct explanation. Knowledge alone does not override orientation-based perception. You can know that the mirror reverses front and back, yet still feel that left and right are reversed when you look. This is not a failure of understanding. It is a reflection of how deeply orientation is wired into perception. Feynman appreciated this distinction between knowing and feeling. Physics explains what is happening, but perception continues to operate according to its own rules. The two systems coexist. The mirror becomes a place where they collide. The illusion also highlights the difference between intrinsic and extrinsic directions. Intrinsic directions are defined within an object itself. Extrinsic directions are defined relative to the environment or observer. Left and right are intrinsic to the body. Up and down are largely extrinsic, defined by gravity. The mirror reverses neither intrinsically nor extrinsically, but orientation causes intrinsic labels to be reassigned. This reassignment is invisible because it happens instantly. The brain does not announce that it has changed coordinate systems. It simply presents the result as a perception. By the time you are aware of seeing the reflection, the orientation-based interpretation is already complete. The mirror thus reveals that perception is not a direct mapping from world to mind. It is a negotiation between sensory input and internal reference frames. Orientation is one of the strongest reference frames we possess, and it overrides simple geometric reasoning. Feynman used examples like this to show that misunderstanding often arises not from complexity, but from misplaced confidence. We are confident that we understand left and right, so we assume the mirror must be doing something strange. We rarely consider that our own orientation-based thinking might be the source of the strangeness. Once orientation is recognized as the key factor, the mirror becomes predictable. Any time you imagine an object or person with a certain orientation, you can predict how left and right will appear. The mirror is no longer mysterious. It simply triggers an orientation shift that the brain misattributes. This insight also generalizes to other areas of science. In relativity, observers in different orientations and states of motion disagree about time and space. In quantum mechanics, measurement orientation affects outcomes. The mirror is a small, everyday example of how perspective and orientation shape reality as experienced. Feynman believed that cultivating awareness of such effects makes one a better thinker. It teaches humility toward intuition and respect for careful description. The mirror does not deceive us. It reveals how we deceive ourselves by assuming that our orientation-based view is universal. The illusion of left-right reversal persists because it is useful in daily life. Treating the reflection as another oriented person helps with grooming, coordination, and interaction. The brain prioritizes usefulness over accuracy. The illusion is a feature, not a bug. Yet once seen clearly, it becomes a powerful lesson. Orientation is not a passive background. It actively shapes perception. The mirror simply provides the contrast needed to notice it. In the end, the mirror stands as a silent demonstration of how much of what we see depends on how we stand. Change the orientation, and meaning shifts. The reflection has not changed, the physics has not changed, but the interpretation has. That is the heart of the illusion, and that is why orientation, not reflection, creates the sense that left and right have somehow been reversed. The idea that Feynman's insight reveals how perception shapes what we think we see, moves the mirror question beyond optics and into the deeper territory of how the human mind constructs reality. At this level, the mirror is no longer the main subject. It becomes a lens through which we can observe our own thinking habits. What seems like a simple visual trick turns out to be a demonstration of how strongly perception depends on interpretation, expectation, and mental shortcuts. Human perception is not a passive recording device. The brain does not simply receive images and display them like a camera. Instead, it actively builds a model of the world using incomplete information. Light enters the eyes as patterns of brightness and color, but meaning is added later. Shapes become objects, movements become intentions, and reflections become people. This construction process happens so quickly that it feels automatic and unquestionable. The mirror exposes this process because it presents information that is visually accurate but conceptually unfamiliar. The reflected image obeys the laws of physics perfectly, yet it conflicts with how we expect bodies to behave in space. Faced with this conflict, the brain does not abandon its expectations. Instead, it reshapes the interpretation of what is being seen. Feynman often emphasized that nature does not care about how humans prefer to think. The universe follows rules that are consistent, whether or not they align with intuition. The mirror follows those rules faithfully. The discomfort arises because human perception evolved to prioritize survival and usefulness, not abstract truth. When those priorities clash with physical reality, perception bends. This bending is not a flaw. It is a feature of how intelligence works. The brain is a prediction machine. It constantly guesses what should happen next and compares those guesses with incoming sensory data. When the guesses mostly work, perception feels smooth and effortless. When they fail, confusion arises. In the case of mirrors, the brain predicts that a human-shaped figure facing us must have a certain orientation. It predicts that left and right should behave the way they do in social encounters. When the reflection violates these predictions, the brain resolves the mismatch by labeling the experience as a left-right reversal. This label feels explanatory, even though it is technically incorrect. The power of this label comes from language. Words like left and right feel concrete, but they are actually relational concepts. They depend on perspective, orientation, and reference frames. When language is applied loosely, it creates the illusion of explanation without precision. Feynman warned against this kind of explanation, where familiar words hide unfamiliar truths. Once the phrase mirrors reverse left and right is learned, it becomes part of cultural knowledge. People repeat it without questioning it, reinforcing the illusion across generations. The explanation survives not because it is accurate, but because it feels satisfying. It matches what people think they see. Feynman's contribution was to strip away that satisfaction and replace it with clarity. He showed that what we think we see is not always what is physically happening. The mirror does not reverse left and right. Our perception does, because it insists on interpreting the reflection as an oriented human counterpart. This realization has broader implications. It suggests that many things we believe about the world are shaped more by perception than by reality. Color, for example, does not exist in objects. It is created by the brain in response to different wavelengths of light. Sound does not exist in the air. It is created by the brain in response to pressure waves. The mirror illusion fits into this pattern perfectly. What makes the mirror example especially powerful is its familiarity. Unlike abstract scientific experiments, mirrors are part of daily life. They feel simple and obvious, When something so ordinary turns out to be misunderstood, it shakes confidence in intuition itself. Feynman valued this discomfort. He believed it was essential for real understanding. Comfort, in his view, was often a sign that questions were not being asked deeply enough. The mirror teaches that even when something feels completely understood, there may still be hidden assumptions guiding that feeling. Perception also explains why different people respond differently to the explanation. Some immediately accept it and feel a sense of relief. Others resist it, feeling that it contradicts their lived experience. This resistance is not ignorance. It is the brain defending a model that has worked reliably in everyday life. Understanding the mirror illusion does not require abandoning perception, but recognizing its limits. The reflection still looks the same after the explanation. The feeling of left-right reversal may still occur. What changes is the interpretation. You begin to see the illusion as something your mind is doing, not something the mirror is doing. This shift in perspective is subtle but profound. It trains the mind to separate observation from explanation. You observe the reflection, you explain it using physics, you notice the gap between the two. That gap is where learning happens. Feynman often argued that science is not about having the right answers, but about asking questions in the right way. The mirror question is a perfect example. Asking why mirrors reverse left and right leads to confusion. Asking what mirrors actually do leads to insight. This habit of questioning perception becomes especially important in modern science, where many phenomena directly contradict intuition. Quantum mechanics defies everyday notions of particles and waves. Relativity defies everyday notions of time and simultaneity. In each case, perception and common sense must be carefully examined rather than trusted blindly. The mirror prepares the mind for this challenge. It shows in a gentle and accessible way that the brain can be confidently wrong. It also shows that this wrongness is understandable, predictable, and correctable through careful thinking. There is also a philosophical dimension to this insight. If perception shapes what we think we see, then reality as experienced is always filtered. We never encounter the world directly. We encounter a version of it constructed by the mind. The mirror makes this filtering visible. This does not mean reality is unknowable. It means that knowing reality requires tools beyond intuition. Mathematics, measurement, and controlled experiments provide ways to bypass perceptual bias. The mirror's behavior can be described exactly using geometry, regardless of how it feels to look at it. Feynman loved emphasizing that science does not aim to replace wonder with dryness. On the contrary, understanding deepens wonder. Knowing that the mirror is not tricking you, but that your mind is performing a complex interpretive act, makes the experience richer. The reflection becomes a collaboration between physics and perception. Light follows simple rules. The brain builds complex meaning. The illusion emerges at their intersection. Once this is understood, the mirror no longer feels like a puzzle to be solved. It feels like a demonstration running continuously in your home, showing how easily perception can mislead and how powerful careful reasoning can be. This is why Feynman's answer feels mind-blowing, not because it introduces a complicated theory, but because it overturns a comfortable assumption. It forces a reevaluation of how much trust we place in what seems obvious. In the end, the mirror does not reveal a strange property of glass. It reveals a property of the human mind. We see what we expect to see, and when expectation and reality conflict, expectation often wins. Recognizing this is not a loss. It is a gain in intellectual honesty. The mirror stands quietly, doing exactly what it always has. The change happens entirely within the observer. Once perception is recognized as an active participant, not a neutral witness, the illusion dissolves into understanding. And in that understanding lies one of Feynman's favorite lessons. The world is not obliged to make sense to us, but when we learn how to question our own seeing, it often makes more sense than we ever imagined.